There's a common mistake in algebra that shows up when you're simplifying rational expressions. So here, let's simplify this rational expression, 2x minus 3 over 2x plus 1. And the mistake that people make is they see this 2x, it's in the numerator and denominator, and they know that, well, sometimes when you see the same thing in the numerator and denominator, you can cancel them, like this. And that leaves behind minus 3 over 1. And so this is minus 3. Is that right? No, that's not right. So all of this is wrong. If you were simplifying 2 minus 3 over 2 plus 1, could you cancel the 2's? Well, if you did, you'd end up with minus 3 like before, but what you actually get is 2 minus 3 is minus 1, and 2 plus 1 is 3. So we get minus 1 over 3 instead of minus 3. So these aren't equal. These are very different. It's not always the case that they're reciprocals. That's just a coincidence about this one. So this way of quote-unquote canceling is actually wrong. So let's back up and do it the right way. So 2x minus 3 over 2x plus 1. So to simplify rational expressions, you need common factors in the numerator and denominator. And remember, a piece of a sum like this, 2x and this 3, these aren't called factors, these are terms. A factor is a part of a product, not a part of an addition or subtraction. So the only factor in the numerator is 2x minus 3. The only factor in the denominator is 2x plus 1. So the numerator and denominator don't have any common factors, and so there's nothing we can cancel in this fraction. So this rational expression is actually already simplified, so we don't have to do anything to simplify it. The place where this mistake most often happens is when you're adding rational expressions. So let's see what this mistake looks like if you're adding rational expressions. So let's just take 2 over x minus 1 plus maybe x over x plus 2. All right, so to add these rational expressions, we need to produce a common denominator. And to make a common denominator appear on this right-hand piece, the missing part of the denominator we want is x minus 1. So let's multiply the numerator and denominator by x minus 1. And in the left-hand piece, the missing part of the denominator is x plus 2. So let's multiply the numerator and denominator by x plus 2. Okay, so on the left, that gives us 2 times x plus 2, and on the right, plus x times x minus 1 over, and then the common denominator is going to be x minus 1 times x plus 2. And it's at this point that I often see students make this mistake. So they see, in the numerator there's an x plus 2, and in the denominator there's an x plus 2, so I can cancel these, right? No, that's not right. If you could also cancel the x minus 1, and then this wouldn't have any denominator at all, which seems somewhat unlikely. So this x plus 2, it's a part of this left-hand sum, but this it's part of this left-hand product, but this piece on the left is itself part of a sum. So this numerator is a sum and not a product, so you cannot cancel pieces like this. That's repeating the same mistake that we made a minute ago. So how do we fix this? Well, we fix this by not trying to cancel things in the numerator and denominator. Just simplify the numerator. So in the numerator, we can distribute this 2. While we're at it, let's distribute this x. We get 2x plus 4 plus x squared minus x all over x minus 1 times x plus 2 And then in the numerator, we can combine like terms. We get x squared. There's a 2x minus x, so that's plus x plus 4 over x minus 1 times x plus 2. Okay? Now to simplify this further, we should check if the numerator factors, but in fact it doesn't. Since we can't factor in the numerator, there's no chance that we will be able to cancel one of the factors of the denominator. So at this point, this is as simplified as it's going to get. So when you are adding rational expressions, be very careful about canceling things in the numerator and denominator. You can only cancel if you have a common factor, not a term. You can only cancel if you have a common part of a product, not a common part of a sum.